Hi, my name is Rahul Trisala and I work as an AWS Solution Architect and a Udemy instructor. AWS Bedrock has been in general availability for a few weeks, so I thought I'll create a video which will showcase an end-to-end use case in the manufacturing industry, and we're going to build that end-to-end use case using AWS API Gateway, Lambda, and AWS Bedrock, where we'll use the Cohere model. If you build this and follow along, it's going to cost you a few cents. This video is part of my AWS Udemy course, which you can check from the link below. Now let's go ahead and see what is the use case we're going to build. In this section, we're going to implement a common manufacturing industry use case where we'll do the text summarization using the AWS Bedrock Foundation Model for faster issue resolution to improve the productivity of technicians. So if you look at any large equipment manufacturer, such as manufacturers for turbines or windmills, you will see that these windmills will be deployed in remote locations. And if there is ever a failure, then you will have a technician who will be at this remote site, will take some pictures and create a detailed issue log. Then these images of the breakdown and the detailed issue log would be accessed by a technician sitting at a remote office through maybe a custom application that's been built. Now the challenge is that once this technician looks at these images and detailed issue logs, sometimes the detailed issue log can be too detailed and time consuming for this technician to look through. So now the question is, how can generative AI help here? One possibility to improve the productivity of technician is to send these detailed issue logs to AWS Bedrock, and Bedrock invokes one of the foundation models and then summarizes the key issue log and sends it back to the technician. Then the technician can look at this summary of issue log rather than the entire detailed issue log to help make decisions faster. Now let's take a look at the architecture that we're going to build as part of this use case. So here we have the user, which is a technician in our case, sitting in some remote office. So I'll invoke a REST API and then send a prompt along with this API request. And this prompt in our case will be a detailed issue log. So once this REST API has been invoked, it is going to trigger a Lambda function, and then this prompt is going to be passed as an event to AWS Lambda function. And then this Lambda function is going to invoke the AWS Bedrock API and query a foundation model that we have selected. So in our case, for this use case, I have selected the Cohere Foundation Model, which we will be using for text summarization. Now, how we can select the right foundational model will depend on a lot of parameters such as modality, whether it's for image generation or for text or summarization, the cost of the foundation model. There are multiple factors. Maybe I'll create a separate video to describe what are the factors that you take into account for selecting the right foundation model. Now there is a little bit of limitation to this architecture in terms of size of the input prompt that you can use for summarization. So you can have the prompt only up to certain characters. The reason being that if the prompt is too long, then we have to introduce another element called as Langchain. But for now, we are just going to stick with this architecture and we're going to provide a relatively short prompt. And when I say prompt, it means the user input. Now the steps that we're going to follow to create these use cases: first, we're going to write the AWS Lambda function. Then we're going to create the REST API using the AWS API Gateway. But before we start writing the Lambda function, there are a couple of prerequisites. One, we have to enable the foundation model in our AWS account. At the moment, AWS requires you to enable all these foundation models by going to the AWS Bedrock service. So in future, if this is provided by default or you have already enabled it, then you can skip this step. So now let me go to the AWS console and show you how to enable these foundation models from the console. Okay, now the first thing we're going to do is how to get access to these Bedrock models. So I'm on the AWS console. I will search for Bedrock, and here you can see Amazon Bedrock. Now I can go on the left side menu, and here you need to scroll down and go to model access. I've already enabled model access on my AWS account, But if you go here and see that you don't have access, then you just need to click on this edit button and then select all the models you want access to and then do a save change. And AWS should be able to provide you access within 15 to 30 minutes. So now if you go to this overview section, it will show you all the models that AWS Bedrock supports at this moment. So if I just click on this, so here you see you have the model from AI21 Labs. So if you have a use case where you require multilingual support, so then this is a great model. And then you have the general purpose one from Amazon, where you have the Titan Embeddings and Titan Text G1. It's still in preview, so you won't have access to that. Then you have Anthropic, then you have Cohere, which is the one which we are going to use for this use case. And then you have the Stability AI. So if you need to generate images, etc., then you use this Stability AI. AWS also provides you with a playground where you can just try it out from the console. So if you go to this playground chat, and from here you can select the model. Say if I select AI21 and then you select the model, and then you can just play around from the console with this model. So I can just say what is my name, and hopefully I should get a response. And you can see here it gives me a response. Hello, I'm an open assistant. How can I help you? Similarly, if you want to generate an image, so you click on image and then you have the Stability AI, and I can say generate an image of a dog. And I just need to fix this spell. And if I just do a run, so you can see it's generated an image of a dog. So now let's go ahead and build our use case end to end. So we'll start by writing the Lambda function for this use case. So I've created a step-by-step guide, but before we start coding for the application, we need to meet some prerequisites. Okay, now let's do that. So the first thing we're going to do is we're going to create an AWS Lambda function. So I'm on the AWS console, so I'll search for Lambda. So I'll click on the create function. Let's call it demo Bedrock. So runtime, I'm going to select Python 3.11, which is the latest version, and then just going to click on create function. Okay, now you can see our blank Lambda function has been created. Now if I can go back to the PPT, you can see as per the Boto 3 documentation, the minimum version for Boto 3 should be 1.28.63 to be able to use Bedrock. And the current Boto 3 version for Lambda that it shows is 1.27. I did a little bit of Google and realized that this is the command that you can use to check the Boto 3 version for your AWS Lambda function. So I'm just going to copy this and go back to my Lambda function. So here, the first thing I'm going to do is I'm going to import Boto 3. Import Boto 3. And then I'm just going to use this print function, which will give me the version of the Boto 3 that is being used in AWS Lambda function. So just click on the deploy, and now let me just test it. So I need to create a test event, so I'll just say test and just do a save. And now let's see what's the version of Boto 3 in our current Lambda function. So you can see the version here it is showing is 1.27.1, and the minimum version that we require is 1.28.63. So we need to upgrade this Boto 3 version to minimum of 1.28.63, and here's a link I found through which you can update the Boto 3 version using the AWS Lambda layers. So let me go to this link. You can also just do Google and find this article. So what I'll do is I'll go to the bottom. Here you can see manually create the Lambda layer that uses latest Boto 3 version. So what you need to do is you just need to run these commands and it will upgrade the version of your Boto 3. So let's do that. So I'll run these commands through the Cloud Shell. So I'll just open that. Okay, now my Cloud Shell has launched. Okay, now let's go to the documentation. And you can see you have to run all these commands that have been highlighted here. So you can replace the Boto 3-my layer. And you can see here we have Boto 3-my layer with any name that you want. So I've already installed all these commands when I was trying out the use case earlier. So I'm going to use a slightly different name, maybe my layer 9. But if you have not installed this before, you can use the same commands as it is. So let's do that. And I will just change my layer with 9. Okay. So I go back and run this mkdir command. Okay, now let's do this pip install. So this takes a bit of time. And now let's do this cd boto3 dash my layer, and I have to change my layer to my layer 9. And cells add a 9. You don't need to add this if you have not installed this before. Okay, now let's do this one. Again, I will change the name. Okay, it will take some time to install, and then finally we have to publish the layer. And so I'll just go to copy this command. And I just need to make the change here, add 9, and I need to add one here as well, and I think that's pretty much it. So now you can see it's created this layer ARN and layer version ARN. Okay, I'm going to copy this layer ARN from here, and let me just do a duplicate. Okay, now I'm on this lambda function that we had created earlier. So I'll just click on this layers, add a layer, and then I'll just specify an ARN, and I'm just going to paste this ARN here, do a verify and add. Now you can see this layer has been added, and you can see a 1 besides the layers. Now if I just go ahead and test this lambda function and see what is a version of Boto 3 that's been installed. So if I just run test, now you can see the Boto version that we have is 1.28.65, and as per the documentation it should be minimum 1.28.63 or more. So in terms of the prerequisites, I think we are good, and we can go ahead and start coding for this function. Now let's go ahead and create the lambda function. So I've written some broad steps so that you can easily write this lambda function. So the first one that we have to do is we have to import the Boto 3 and create the client connection with the Bedrock. So let me just copy it from here. Okay, let's just paste it somewhere here so that it's easier for you to write this code. We've already imported the Boto 3. Next one, let me just comment it out because it's no longer required. This was only to check the Boto 3 version. Now we know we have the right Boto 3 version. Okay, now we have to create the client connection with the Bedrock service. So what we can do is we can just go ahead and search Bedrock 3 runtime. Let me just click on this documentation, and you can see this is the documentation for how to make an API request to the Bedrock service. So the first thing we have to do is import Boto 3. So that we have already done. The next one, we have to create a connection with the Bedrock runtime service. So I'll just copy this and let's write it here. Okay, now we have done that. Now let's look at the next step. So the next step that we have to do is we have to create a request syntax. I get the details from console, and body should be a JSON object. Okay, this is just a guidance for you on how to write the lambda function. So let me just go here, and I think we get rid of this to do implementation. Okay, so this is the second. Now in the documentation, we'll check what is the right request syntax to make this API call. So if I go here, so you have to use invoke model method. So just go here, So you can read a little bit about this invoke model, but this is the method we have to use. So this is how the request syntax should look like. So you have the variable response, and then you have the client.invoke model, and these are the attributes that need to be added. So let me just copy this from here and just go here. Let me just paste it here. Now let's see what all this means. So if you go here, so first one is accept, and you can see it's a string and the default values application JSON. So that's what we're going to keep. So I'm just going to copy it from here and let me just place it here. I mean, it's not a mandatory field, as you can see, only these two are required. The rest of them are optional, but we'll just keep it as it is. Okay, so we have the accept. Now let's look at the content type. Again, it's not mandatory. It's a string. Again, the default values application/JSON. So we'll just use it. It's not actually required, as I said. It's not a mandatory field, but just use it anyways. So next is the model ID, which is a string and it's a required field. So to understand what this model ID really is, let's go to the Bedrock service through the console. So I'll just search for Bedrock in the console. Okay, I'm on the Bedrock service, so I'll click on the left panel and let me just click on text. And now let me just select the model category. So as we discussed earlier, we are using Cohere, and then I'll just select the model from here. And as we discussed earlier, our main use case is summarization. So let me just say hello and let me just run this. And it gave me a response. But now what we can also do is click on this view API request. And you can see it gives the API request attributes. And we can get the model ID from here. So basically what it tells the API request is which LLM model that we are going to use. So if you are going to use AI21, then the model ID would be something like AI21. But since we are using Cohere, so that's what we're going to use. So I'm just going to copy this. And as we saw in the documentation, it's a string. So I will just change it here. Okay, now we have populated most of the fields. The only one that is remaining is the body. So before that, let me just move this a little to the right so that our syntax is correct. Now on how to populate this body field, now I can go to the console and copy this body attributes from here. What I've seen is there's a lot of syntax error when we do that. So what I'll do is I will go to the documentation and populate this field through the documentation. So you can see here in the body, it's required and its bytes are seekable file-like object. Okay, and it varies based on each LLM model that you're going to use. So there is more details on the format and content from this particular URL. So let me just go here and show you. So this is for all the LLMs. So I will go to the Cohere. Now here you can see they have given some data points on how to actually make that request. So you can see here there are three key attributes that you need to populate. The first one is a prompt. So the prompt is obviously the most important one. It's the prompt that the user is going to provide, and based on that, the LLM is going to provide you a response. The second one is the temperature. So what temperature does is it's one of the most important parameters for randomness and diversity. And its default value is 0.9. It can be anything between 0 and 5. So what does this temperature do? So if you put temperature as 0, that means that there is going to be very little randomness. Okay, let me give you an example. Say you are asking chatbot, hi, how are you? And it's going to give you a response, I'm doing good today. So if you put the temperature as 0, then every time you ask it the same question, it's going to give you a same response. Now say if you increase the temperature to its maximum value, it's going to give you a randomized response to the prompt that you have provided. So if you provide the same prompt again, hi, how are you? This time it's going to give you a different answer. So it controls the randomness of response. The third key thing that you need to look at is maximum tokens. So maximum token determines the length of the request and the response. So you can see the default is 20 and minimum is 1 and maximum is 4096. But you also need to be aware the max tokens that you define is going to cost you more. But if you provide much lesser value of this max token, then your request and response is going to be truncated. The other key thing you need to know is that the body field should be a JSON object. Okay, so what I'm going to do is I'm going to just copy this from here and I'm going to replace the body values with this JSON object. Okay, let me just move this back. So I'm only going to use three key attributes: prompt, temperature, and max tokens. Okay, the rest of them I'm going to remove. So I'm just going to do a little bit of formatting. So now let's try and add some values. So what I'll do is I'll just copy these in a notepad and then modify that because sometimes it's difficult. Okay, so we have the prompt string. Temperature, we discussed that we're going to keep the values randomized. So we'll just keep the default value as 0.9. So it's a float, so it's a 0.9. And max number of tokens. So you can see the default token length is 20. And when I just make a request, you will see that request and response both are truncated if they go beyond certain length. And there's a direct correlation between maximum tokens and the length of your request or the number of characters in your request and response. So we'll keep it as default as 20, but later we'll modify when we try out our application. So we'll say 20. And now we have to define the prompt. So we'll hard code the prompt for now and try out our function. Once we're satisfied that our Lambda function is working okay, then we're going to pass a prompt through a test event and try it out. And then finally, once we integrate with the API gateway, then we're going to pass the prompt from the API gateway, which would be stored as a variable in this JSON object and then get a response. So let's say hello. Okay, so I'll copy this from here and just paste it. Now, as we saw in the documentation, this body needs to be a JSON object. Okay, now let's convert it into a JSON object. So we'll say JSON dot dumps and put a bracket here. So let me just copy it from here and modify this. I think I just need to put a comma here. Okay, so I think this looks good. So what we can do is we can try it out, and let me just say response. Okay, and let's see what the response structure is going to look like. So it will be a streaming body and then there will be some content type. Okay, so maybe because it's a dictionary, you can see the response structure is dictionary. So I can just add dictionary element here and say body. Okay, now let's go ahead and try this out. Let me just do a deploy. Okay, now let's just go ahead and test this out. Okay, so it's giving me an error saying access denied exception. So what we need to do is we need to create an IAM role and attach it to this Lambda function. So let's do that. So I'll go to the configuration, and I will also increase the timeout limit. So let me make it 1 minute. Save. And let's look at the permissions. Let me open this particular IAM role. So what I noticed during the testing is that there's no particular role that I can attach to the Lambda function, which will give it access to the Bedrock service. So if I do an add permission, attach policy, and if I search Bedrock here, so I don't get anything. So what I'm going to do is I'm going to give it admin access. I mean, I know it's not a great permission to provide to any service, but for now it should work. So I'll just do an add permission. Okay, now let's go back to our code and let's go ahead and test it out. Okay, so let's look at the functional logs. So you can see the functional logs here. So it's giving me a botocore.response streaming body, and that's what I think we were expecting. Now let's go ahead and convert it into a string. So let me just take a look at my steps. Now we have to convert the streaming body into bytes and then bytes to strings. So let me just do that. Okay. Okay, so we'll say response underscore, let's call it maybe byte, and just a variable, random variable name that I provided should be equal to response, and so it will be a dictionary. So response dot body dot read, and finally we'll convert it into a string. So we'll say response string, and this will be JSON dot, and it will be JSON dot nodes, and we'll say response right. Okay, I think this looks good. So the only thing we have to change is that the body here, once it returns, it should return response byte or the response string. Okay, so this is the response string here that we should get. Now let me just do a deploy, and let's just test it out, and let's see if we get a response from the Bedrock service. Awesome. So I think we have got a response. So you can see the prompt that we had provided was hello, and the response that we have got is, hi, I'm a digital assistant. How can I assist you today? Okay, so we had hard coded the prompt here, and maybe I can change the prompt, say, how is the weather in Lulu? And now let me just deploy. And let me just test it out. Okay, so we got a response. The weather in Bangalore today is sunny with high of 34 degrees Celsius and low of 18 degrees Celsius. And this is the prompt. So now we're getting a response from the Cohere LLM model, but we have hard coded the response. So ideally we should be getting a prompt from an event that's passed on to the Lambda function. In the end user scenario, that request is going to come as part of the API request. But before we create the REST API, let's pass that prompt in form of an event to the test event in the Lambda function. Now, before we do that, let's go ahead and look at the next step in our guide. So this is the final step. So this is the fourth step. I will paste it here because this is where it should be. Okay. Now let's look at what are the steps that we should follow to have that prompt come in as part of a request event and then rather than hard coding the value. Okay, so the first thing that we are going to do is print the event so that we know the event is correct or not. So I will say print and event, and this is the event that we're going to get here. Okay, so the next thing we're going to do is we're going to store the input in the variable. So we'll get the details of the prompt as part of this event, and let's store that somewhere so that we can replace it here as a variable. Okay, so let's say user underscore prompt, which will be equal to, and we'll say event, and let's call the prompt as prompt. So I'll say prompt, and this is a name we'll have to give when we are passing the test event. Okay, now we have the variable user prompt here. So let's go ahead and replace that prompt value in this body request that we're going to send. So we'll say user underscore prompt. So now we are not hard coding the prompt that the Cohere LLM model is going to get from Lambda function, but it is going to be a variable that is going to be passed as a part of the event. So now I'll just do a deploy. Now let's go ahead and create a test event. So I'll go here and say create a new event. So let's call it as prompt test, and here we have to change the key value pair. So let's call this as prompt. That's the key that we had provided, and let's say how is the weather in London. Okay, so this is a format just JSON just to check this correct or not. Okay, how do we save? And now let's just go ahead and test this event. And okay, awesome. So it says the weather in London can be changeable throughout the year. The average temperature is in January, which is the coldest. And you can see how is the weather in London. And you can see in the functional logs, the prompt, how is the weather in London that we had passed. Okay, now we have written the Lambda function. Now we are able to pass the prompt as an event to the Lambda function and then get a response back from the Cohere LLM as part of the Bedrock service. Now let's take a look at the architecture. So we have already written this Lambda function. We have selected the model from the Bedrock service. So only thing we have to do is create the REST API, and then through the REST API, we're going to pass this prompt and invoke this Lambda function and get a response back. So now let's do that. Now let's go and create the last piece of the puzzle, which is creating the REST API from the AWS API gateway. So here are the broad steps. So we're going to create a REST API from the API gateway. Then we're going to create a resource, demo Bedrock, and then we're going to create a method get. Let me head over to the console. So I'm on the console. Let me search for API gateway. So I'm on the API gateway console. You can see API gateway is introducing a new console. So I'll just do a create API, and then I'll just go to REST API, do a build, and I'm going to name it as demo Bedrock, and we'll just go to create API. Now it's created this API. So next we're going to create a resource. Now let's just call it as demo text summarization. I'll just do create resource, and then we can just go here and click on create method, and I'll say get, and then we have to provide the Lambda function that we're going to use. So I'm just going to go here and copy this demo Bedrock, This Lambda function is going to be triggered every time someone invokes the REST API. So saying invalid dash bedrock. Okay, so here it is. So I'll just do a create method. So you can see now on the left we have the resource demo text summarization, and then we have the get method. So we need to make some changes. So if I go back to the template, so first thing we have to do is go to the method request, and in the URL query string parameters add a input parameter. So let's go to the method request here, and then URL query string parameters, because we are going to add the prompt as a URL query string parameter. So let me just do an edit here, and I'll go here, add query string, and let's call it as prompt, because if you see here, we have the event value as prompt. So just go here and I will say required, and I'll do a save. Next, we're going to enable the request validation. So I'll just do an edit, and here request validator, I'm going to say validate query string parameter and header. So without the query string parameter, you will not be able to make an API request. So I'll do a save. Okay, next we need to go to API gateway integration request and make some changes. So I'll just go to integration request, and then just scroll down and look at this mapping template. So click on create template, and in the content type we need to provide application/JSON. So that's what we're going to do. And then in the template body we have to update this. So I'll just tell you what it means. So what it means is that the prompt user is passing as an API request is converted to event and passed on to the Lambda function. This template body is written in a templating language called as Velocity language templating. So that's what we are doing here. So we'll just do a create template. Okay, so now this change has been applied. Okay, now let's go ahead and deploy this API to a stage. So we'll say deploy API, new stage. Let's call it as dev. We'll deploy. Okay, now let's go ahead and test this API. So I'll go to resources and do a get and go to this test. So maybe I will give it a prompt saying which is the best foundational model in AWS Bedrock. So we'll just start with something simple and see what is the response that we get. Okay, so we have got a response. Let me move this to a little left, and you can see the response body. So we have status code 200, and here it says there are several foundation models in AWS Bedrock that are designed to provide a secure and compliant foundation for AWS deployment. And it gives me some more details. So you can see, I think the answer seems to be fairly reasonable. And if I see the prompt, here is the prompt, which is the best foundation model in AWS Bedrock. Now let's go ahead and check if it can summarize something meaningful. So I don't have any meaningful issue log data that I can request the Bedrock to summarize for me, but I found something interesting. So here is an article. I just did a little bit of Google, best football players in the world. So maybe what I'll do is I'll just copy some of the text here and see the response that we're going to get. Okay, let me go to API gateway and let me change the prompt to what we just saw. Okay, now let me just test it out. So here is the response. It says it is difficult to say who is the best football player in the world, as it is a matter of personal opinion. Some of the top players in the world include these three. So it seems fairly accurate. And if we see what was the prompt, who's the best football player in the world, the question will be asked, the answer will be never unanimous. And then you can see it gives some more details, but looks like it's giving a fairly reasonable answer in summarizing what was there in this passage. So hope you found this use case and end-to-end demo useful. Thank you.